Chapter 9.3, Graphing Univariate Data. Univariate refers to uni meaning one variable. So we're actually one thing that we're actually surveying. So for example, we could talk about test results on an exam that a class did. It's the actual score that people got on the test that's what's varying. There's only one variable. So that's what we mean by univariate. Our example here is the number of pets owned. We ask you how many pets do you own? It's 1, 2, 3, 4. It's a discrete number like that. So that's what we mean by univariate. Later sections we'll get onto multivariate data where we have more than one variable, but that comes later. Okay, so we're looking at different ways that we graph this. The first thing we're looking at is a dot plot. Literally this is just dots on a scale. We end up with a line like this with dots coming up. It looks a little bit like a bar graph or a histogram, but it's done with actual dots. We only use this for categorical or discrete data, typically not for continuous data. Alright, so here's my example here, worked example 5. Draw a dot plot to illustrate the following data that represents the number of pets owned by each student in a class. So here's a class of some 24 odd students that we've surveyed. We asked them how many pets they had. First person had 2, the next person had 5, this person had 8, lots of pets, and so on. He only had 1 pet, this guy had 0 pets, and so on. Alright, so what we need to know here is, what's my biggest value and my smallest value? Typically we want to know that whenever we're drawing some sort of graph. So, my smallest value is obviously going to be 0 because I can't get less than 0 pets. My biggest value, well, we've got an 8 in there, there's an 8, nothing else there is above 8. So what this tells me is that my number line that I'm going to use to graph this must go between 0 and 8. These spaces should be spaced out very evenly, and typically it would be good to get a ruler and measure the distance and make sure it's the same for all of them. So we're going to go between 0, 1, 2, 3, 4, 5, 6, 7 and 8. And all we're going to do is put a dot on the line for each one of the results that we have. So we go through our data. So 2, we put a dot on there. 5, 8, 6, 2, 4. And we try and keep them somewhat lined up. 3. It's a little hard on this one because I've got no lines, whereas your book will probably have some lines on the page to help you keep them in lines. 4. So he should be in line with him. 2, 1, 8, 3, 4, 0, 3, 1, 0, 3, 5, 1, 4, 2, 1, 4. And you can see it's somewhat like a graph. Try and keep those dots lined up. These guys here should all be lined up. It's a little bit hard to do on my page here, but that's pretty much how you should get it done. Alright, the next thing we're going to look at, stem and leaf plots. The stem and leaf plot is good when we have a large amount of numerical data. Sometimes we'll combine that data into groups and so on, but the good thing about a stem and leaf plot is we're grouping data, but we're not losing any of the individual scores. Alright, so how do we go about that? Just like before, what's our lowest number? What's our biggest number? So let's have a look at my actual question. A class obtained the following percentage results rounded to the nearest whole number in a science test. Express the following data as an ordered stem and leaf plot with a class interval of 10. So basically we're going to create a stem and leaf plot and the groups are going to be 10. So here's what we've got to do. What's my lowest number? My lowest number would be 42. my biggest number. If I look through all my data there, my biggest number must be 90. So my data's got to go between 40s to the 90s. We're using an interval size of 10, so that's why I say from the 40s to the 90s. So we start with a stem. We're going to have 4 to represent 40s, 50s, 60s, 70s, 80s, 90s. Alright, now that forms my stem, and I'll rule a line. And over this side I'll have my leaves. So we run through the data and we put it on here. Alright, so 69, so that would be 69. 54, 54, 91, yeah, that's not quite right, but that's okay. We don't go up to 100, so I know I don't need to go past him. 42, 73, 75, 81, 96, 88, so see, 88, see how I'm building this up, 76, 65, so 65, once again I'm trying to keep these columns lined up, 83, 74, 76, 82, 61, 57, 64, 64, 58, 79, 83, 90, 73, 60, 60, and 51. 51. Now, to complete this table, what I really should do is rewrite it, but put these numbers in order. So, I've got 40, 50, 60, 70, 80, 90. Draw my stem. Now I'll draw my leaf, but I'll put the numbers in order. So, there's only one there, it's 42. Now if I look at this, that's my first number, a 1, a 4, a 7 and an 8. 0, 1, 4, 5, 9. I've got 2 3s, I've got a 4 and a 5, 2 6s and a 9. I've got a 1, a 2 and 2 3s, and an 8, and 0, 1, 6. Alright, so there's a little bit neater now. Now, one thing I haven't done is my key, which I need to tell people what this actually means. So, key, 5, 1 equals 51. So I'm making it clear that the stem of 5 and the leaf of 1 is the number 51. So this number here represents 74, for example. And you can see it's sort of a bit of a sideways graph once again. And we've grouped my data into the 40s, 50s, 60s, 70s, my interval size of 10.